During the last 9 videos, we built a movie recommendation system together. We encoded the movies with a Tensorflow library, stored the data in Postgres, and used the vector search capabilities of PGVector. In this final video, I would like to look back at the challenges and limitations of the solution that we built and give a brief analysis to working with ML models and JavaScript, in particular the usage of TensorFlow. I selected TensorFlow for this project for several reasons. First of all, it's one of those few libraries for JavaScript that can do what we need, create vector embeddings for text values. In the current times where everyone is talking about AI and machine learning, JavaScript still has to catch up. But it wouldn't be fair if I don't mention other ML libraries I looked at. For example, Node.js is a machine learning framework for building AI assistants and chatbots. Keras is a popular JS framework for deep learning. Synaptic, a neural network library for Node.js. Also Brain.js, library for neural networks written in JavaScript. Mind is another neural network library for Node.js and the browser. Then we also have Next.js, a JavaScript library for training deep learning models. And finally, ML5.js, an open source, friendly, high-level interface to Tensorflow.js. And I ended up selecting TensorFlow for the reason that based on my research, it was the most widely used JavaScript library for machine learning. Therefore, it has a bigger community and is potentially easier to get around in case of any errors. TensorFlow also had exactly what we need, a model and library universal sentence encoder that encodes into vectors text descriptions. It is simple to use and the quality of vectors seems to be reasonable. And TensorFlow did the job quite well. However, my experience wasn't completely smooth. And if you watched the complete series, you notice that from time to time I was giving you recommendations on TensorFlow usage to avoid potential issues. And let's go back and I'll give you some example of those potential issues. First of all, you need to be careful where exactly you install TF.js node. It's very picky to the path that contains spaces or any other, not really special characters, but let's say semi-special characters. The solution is easy, you just need to be quite careful with whatever you put in your path. But the error is quite puzzling if you see it for the first time. Later I just realized, use simple path, don't put any spaces, don't put any semicolons or whatever like characters I wanted to use. Then if you see an error saying that fetch failed, it might that you do have some connection issues, even though you might have an impression that your internet is working just fine. It's a different error to when you don't have internet at all. So I was looking at that error, then I was Googling and trying different solutions. In the end, nothing helped till I just switched off my Wi-Fi, switched it on again, and then boom, everything started working again. By the way, the TensorFlow library needs to load the model, so you do need the internet for it to work, just if that part wasn't clear enough. Next one, when you start using universal sentence encoder, you might run into an error which states no backend found in the registry. I spent a good chunk of an hour Googling possible reasons for that and trying different solutions, up until I realized that I need to include TensorFlow TF.js node explicitly. It does make total sense, and even the examples on the README page of the TensorFlow JavaScript library do have the dependency included, even though the object from the dependency never used later in the code, but we do need it. And probably it's completely fair and completely logical. However, I missed that, and I'm not probably so attentive reading the documentation line by line, so that was a problem. And these issues are totally not a deal breaker, and no one expects an open source library to be just perfect. If anything, I should open the issues and help making those improvements. The reason for this at moments shaky experience, I believe that till now the demand for machine learning in JavaScript was quite low. If you are still on Reddit and, like me, following the conversations about local large language models, you might have noticed that in almost all the cases when it comes to the programming languages, everyone is using Python. Historically, Python has been more popular for machine learning compared to JavaScript. Python has a rich ecosystem of libraries, data science-friendly features, and not to mention that many academic institutions and researchers use Python for machine learning experiments and teaching. And JavaScript at the same time has its historical focus on web development. However, also historically, JavaScript has surpassed so many expectations, so I wouldn't be surprised to see a lot of improvements and the growth of community around JavaScript and machine learning soon. However, if you are using JavaScript but you're not yet ready to run models locally with TensorFlow on your machine or using other similar tools with JavaScript, you can also rely on APIs, on some remote APIs. For example, for starters, you can use Hugging Face API to get those vector embeddings using JavaScript API calls. And you do have a variety of models, so you can select depending on how long you are ready to wait for the generation of the embeddings or how good you want to have those vectors. So to balance that quality and the time, you can select the best model which fits your needs. So for our movie recommendation project, which is written in JavaScript, what we could have done is to use an external API such as Hugging Face for single calls to get a vector embedding for a search phrase which our user enters. And this would be done via HTTP request to the hosted inference API. Meanwhile, the body of the movies, the dataset, that bulk of data, you can encode separately with a different tool. For example, a Python library. However, remember that you do need to use the same model to encode the search phrase as well as the dataset, so that you have kind of same vectors, same dimension, and same model which figured out what kind of vectors to have. If you want to learn more on the topic, leave the suggestions in the comment section of this video. With this, it was a joy to build a project together. If you enjoyed this series, check our other videos. Also, please like and subscribe, and I'll see you building something else cool in the future.